This research paper explores the need for incorporating sound sources into urban noise visualizations, aiming to understand the importance of this information for various city stakeholders. Through qualitative interviews with nonprofit environmental organizations, city technical services, officials, and non-specialists, the study reveals three distinct uses of sound source representations. 1. Noise-related complaints for industrials and specialized citizens. 2. Soundscape quality assessment for citizens. And 3. Guidance for urban planners. The paper begins by discussing the limitations of current noise maps and monitoring platforms, which failed to accurately gauge the sound perception associated with different sound environments. It highlights the significance of differentiating between various sound sources, such as voices, construction work, or road traffic, as they are perceived differently. Recent research has shown the value of visualizations of multiple sound sources in urban environments, introducing another level of complexity to these visualizations. The study's methodological framework involves conducting interviews with a diverse panel of stakeholders, including those involved in creating, consulting, and making decisions based on noise-related visualizations. The findings from these interviews provide valuable insights into the perspectives and preferences of stakeholders, revealing that they require visualizations that use indicators adapted to their target audience and enable data accessibility. The paper also discusses the importance of incorporating multi-source information into noise visualizations, which could enhance the analysis for different stakeholders. This is particularly significant for understanding the diverse use cases that emerged from the interviews, such as noise-related complaints, soundscape quality assessment, and guidance for urban planners. Additional complementary topics are explored, including the limitations, assumptions, and future work discussed in the research. In conclusion, this study emphasizes the importance of considering sound sources in urban noise visualizations to provide a more comprehensive understanding of urban soundscapes. By analyzing the needs and preferences of various stakeholders, the research aims to develop visualizations that cater to their requirements and enhance decision-making processes related to urban noise management. The research paper discusses the importance of noise management in urban environments, focusing on the utilization of source recognition tools by various stakeholders. It begins by outlining the roles of different groups involved, including city officials, urbanists, and acousticians. The paper then describes the structure of interviews conducted with these stakeholders, which gather information on their past experience, current practices, and potential use of such tools. A key aspect is the demonstration of existing platforms, such as the noise map and rumor, which are used to monitor and visualize noise levels. The harmonica index is highlighted as a useful indicator for understanding sound environment components. The paper explores the willingness of stakeholders to employ these tools in their professional activities, emphasizing the need for effective noise management strategies. The discussion on pages 5 and 6 of the research paper focuses on the strengths and weaknesses of existing noise mapping and observation platforms. It explores participants' insights on enhancing these platforms, particularly regarding the visualization of multiple sound sources. The introduction of a sound classification algorithm, PAN 1/3 October, prompts opinions on visualizing specific sound sources like traffic, voices, and birds. Participants are also asked about additional stakeholders who might be interested in similar visualizations. The Lasso platform is demonstrated, showcasing its spatio-temporal datasets and functionalities, including a scale for sound presence and a graph for eventfulness and pleasantness. The discussion highlights the need for platforms that provide multi-source visualizations of the soundscape, referred to as MS platforms. Throughout, the focus is on improving existing platforms to better serve users and stakeholders. The research explores the use cases for noise-related complaints, soundscape exploration, and guidance for urban planners. For noise-related complaints, the focus is on citizens familiar with acoustic indices, addressing noise levels with source recognition. Key requirements include detailed data at precise intervals, noise indicators, and a need for separate platforms for distinct noise sources. For soundscape exploration, the target audience is the general population, aiming to provide a broader representation of the soundscape. Urban planners require precise, localized data for noise assessments, often integrated with other environmental factors. The research emphasizes the importance of accessible indicators, precise data, and the need for incremental complexity in visualizations. It highlights the significance of source recognition. Urban planners focus on localized scales, and the importance of bridging the gap between technical data and public perception. In the context of urban noise management, this research paper discusses the importance of understanding how different city stakeholders perceive and utilize noise representations. It emphasizes that these representations can be enhanced by incorporating information about sound sources, which could benefit various stakeholders such as the general public, urban planners, and industrial stakeholders. The paper highlights 3 distinct applications for noise representations: noise complaints, soundscape exploration, and guidance for urban planners. For each application, the choice of noise indices should be carefully considered, either by promoting current indices or designing new ones tailored to the target city stakeholders. Data transparency is crucial to avoid misinterpretation of the data. In terms of noise indices, the harmonica index and lasso diagram are appreciated for their relevance and accessibility. However, there are concerns about their complexity, suggesting a need for simpler, more intuitive indicators. The paper also emphasizes the importance of providing raw data access and clear descriptions of methods of calculation or measurement to instill confidence in officials regarding the potential interpretation of data by citizens. The paper concludes that the integration of sound source information into noise observatories could significantly enhance the usability and relevance of these platforms for various stakeholders. It also underscores the need for a more nuanced understanding of how different stakeholders perceive and utilize noise representations, as well as the importance of data transparency and accessible noise indices. This research paper discusses the SENSE project, which aims to develop a new generation of noise monitoring systems that can be integrated into urban planning strategies. The project focuses on the development of a low-cost, IoT-based noise sensor network that uses advanced signal processing techniques to identify and classify different urban sound sources. These sensors are designed to be deployed in large numbers throughout cities, providing detailed information about noise levels and sources across various urban environments. The paper also highlights the importance of public engagement in environmental noise management. It references several studies that have demonstrated the effectiveness of innovative tools for informing the public about environmental noise in cities and assisting decision-making processes. For instance, the RUMEUR network in the Paris region and Barcelona Noise Monitoring Network are cited as examples of successful initiatives that use georeferenced data to model urban soundscapes. Moreover, the paper emphasizes the role of visualization in understanding and communicating environmental noise data. It points out that visual analysis of environmental noise data can provide valuable insights into noise pollution patterns and trends. To this end, the paper mentions the use of uncertainty visualization for exploratory analysis of land cover change as an effective method for evaluating the use of visualization in data analysis. In addition, the paper discusses the use of advanced signal processing techniques for identifying and classifying urban sound sources. It references the spectral trancoder, a tool that uses pre-trained urban sound classifiers on undersampled spectral representations to identify different types of noise sources in urban environments. This approach is considered innovative because it allows for the detection and classification of various sound sources using low-cost sensors, making it a promising solution for large-scale noise monitoring networks. Finally, the paper concludes by highlighting the potential benefits of integrating these technologies into urban planning strategies. By providing detailed information about noise levels and sources, these systems can help policymakers and urban planners make more informed decisions about city development and noise management initiatives.